Swayam Prabha. Digital India. Educated India.
Welcome to our discussion on environmental economics. And in our last couple of sessions, we were discussing different types of market-based instruments for pollution control. We have discussed the effectiveness of such instruments under different conditions, and we have also discussed about Porter's hypothesis in this context, wherein he said that regulation as it is perceived by the traditional wisdom is not always bad. Rather, a properly designed and implemented regulation can actually motivate the firms for innovation, and that leads to a win-win situation wherein the firms produce lower amount of pollution, at the same time higher amount of output. We have also discussed the counter argument of Porter hypothesis, but because of its importance in firm performance and competitiveness, a large number of empirical studies have been taken place to basically estimate and examine the validity of Porter's hypothesis. In today's lecture, what I would like to do, I would like to share one of our studies in that context. This will give you several new insights about the Porter hypothesis, new insights about the environmental regulation, new insights about the alternative mechanism in the context of developing countries like India. So, the title of our paper that I am going to discuss today is, does win-win opportunity always result in pollution abatement? An application of directional distance function to Indian cement industry. Why we have taken Indian cement industry for our study? Because cement industry is one of the most polluting industries in terms of CO2 emission. That is why we would like to examine the role of the regulation in the context of cement industry, and specifically we will throw special light, we will shed light on Porter hypothesis per se. This particular article has been published in the Journal of Developing Areas. Those who are interested more and detail about the paper can go through. Here I would discuss only the crux of the story, that means the paper in brief. Now, before we discuss about the paper, a brief preamble, the background. As you know that industrialization to achieve higher economic growth has been the major policy objectives of almost all the economies, and as a result of which environmental degradation has been the inevitable consequence of such industrialization, leading to global warming and climate change. So what is required now is growth in terms of producing more goods and services with accountability. That means the productive units must be eco-efficient. They need to produce maximum output with minimum undesirable byproduct. However, such accountability from the producer's point of view cannot come automatically. Why? Because if you think of the benefit of pollution abatement is mostly enjoyed by the society at large, while the cost is incurred by the private firms. So when the private firms' objective is only to maximize their profit, natural question is then why should they become eco-efficient? Why should they go for pollution abatement? In that context, Porter hypothesis, it emphasizes the role of regulation, which says that regulation is actually not always bad. Firms need not sacrifice their financial performance in terms of profit, revenue, so on and so forth, as they think, because the firms they believe that pollution abatement requires diverting some of their productive resources to pollution abatement from production of goods and services. So, complying with the environmental regulation and standard will definitely reduce their competitiveness compared to others who are not subjected to such compliance. So, in that context, Porter said that regulation may result in innovation and therefore the firms can actually become more productive efficient. Their productive efficiency may go up, their environmental efficiency may go up, they may produce higher amount of output. At the same time they might be able to reduce their pollution. So this is basically the preamble. In that context, we will empirically examine what actually happens to Indian cement firms if we impose any such a regulation. So there are two objectives in this paper. Firstly, to examine the existence of any win-win opportunity for the Indian cement firms. That means whether regulation actually results in higher amount of output and lower amount of pollution. Secondly, which is more important, while most of the existing studies they basically examine the validity of Porter hypothesis in terms of checking the existence of such win-win opportunity. What we are going to do is to examine whether such win-win opportunity, even if it exists, can always result in pollution abatement or not. And we are going to discuss our argument applying a methodology adopted from data envelopment analysis, which is basically based on production economics. I am not going to discuss in detail about the methodology, the mathematical formulation, because that is quite involved. Those who are interested may kindly consult with our detailed paper, as I have already cited previously. Now, why production economics here? If you recall, in our microeconomic theory, we studied about production function. What does that production function says? Production function basically says that it is a relationship between input bundle with maximum attainable output given the technology. Now the question that comes to our mind is how to decide about that maximum attainable output. Who will decide that? In that context, production economics becomes handy. Production economists, they developed a tool wherein they collect the input and output information for all the firms for a given industry. Then they construct one frontier based on the best performers in the industry. The firms who are operating on the frontier, they are called efficient. The firms who operate inside the frontier, they call inefficient. That means for the inefficient firms, it is possible to reach the frontier and thereby gain efficiency without using no further input and without using no further monetary, without incurring further monetary costs. Now we will discuss that our argument based on this simple diagram. In this diagram, we have constructed one such frontier ORSTB. This is the frontier. In the y-axis, we measure good output Y, which is basically cement in this context. In the x-axis, this B indicates undesirable byproduct, which is carbon dioxide in this context. Now, if you look at the very shape of the frontier, production frontier, or this is also called as output set, that as undesirable output increases, initially production of cement also increases, but then at a certain stage it is constant, and then the output comes down and the productive units produces more and more CO2 only. This is purely related to the structure of technology. The structure of technology is such that after some point of time, you will generate more and more CO2. So there are two output set here. One is called a regulated output set. That means we assume the presence of environmental regulation. That means the firms, they need to dispose their waste or bad output in a costly manner, because any type of disposal, pollution abatement is costly. However, we have constructed another frontier which is called unregulated frontier, which is given by O Y double star RSTV. Obviously, the size of the unregulated output set is much bigger than the regulated output set. The logic is very simple, because when there is no regulation, when the firms are unregulated, then they can simply dispose their bad in the environment freely. So disposal of bad is a free activity, while in presence of regulation, such disposal is a costly activity. So this is called regulated technology. Now what we will do, the way we have drawn the diagram, you can look at that there is only one common point between the output set and the y-axis, which is basically 0. That means if the firms, they want to reduce the bad output, they need to actually reduce their good output also. So if they want to produce 0 amount of undesirable output or CO2, they should actually stop their production. No production of cement is possible without producing minimum amount of CO2. And that property in the language of production economics is known as null jointness. Null means 0. Null jointness means, that means the firms can reduce their bad output only by reducing the good. And then we also assume in this case, let us assume that initially the firm is point A. Okay, sorry. Initially the firm is at point A, producing B0 amount of carbon dioxide and Y0 amount of cement. In this context, if regulation is imposed and the firms, they go for pollution abatement, then what will happen? The firm can actually reach the frontier by A1 direction. And then what will happen? When the firm reaches to the frontier, the amount of bad output reduces from B0 to B star. Amount of good output increases from Y0 to Y star. That means this simple diagram can indicate that a regulation can actually result in a win-win opportunity, because by moving to the frontier, by being environmentally efficient, the firm can actually reduce their bad output and increase their good output. So A1 in the literature is called direction vector. So that means a specific direction through which a firm is trying to reach the frontier with an objective to become efficient. Now the question is there any guarantee that the firm will always move into A1 direction? If you look at the direction vector is this, and it is defined as 0, y minus b. Why this is so? 0 means they are not reducing the input at all, neither they are increasing also. Now y with a positive coefficient indicates they are actually increasing the good output, and minus b indicates they are reducing the bad. So in this study we have defined environmental efficiency in this way: capability of the firms to increase their good output, reduce their bad by same proportion. Why we have assumed same proportion? Because of simplicity's sake. If we assume same proportion, then it is easy to estimate from the mathematical formulation. Let us not go into the detail of the mathematical formulation, which is not possible to discuss in one lecture. But what the point of what we were discussing, a movement from A to A1 direction helps the firm become more efficient and enjoy win-win opportunity. But is there any guarantee that the firm will always move in A1 direction? Rather, there is one more option available to the firm. What is that option? The firm can always move to AR direction. And when the firm is moving to AR direction, then what is happening? The firm is actually maintaining its pollution level as it is, but increasing the bad. Now the question is, how is it possible? When the regulation is there, you must comply with the standard. Then how is it possible for the firm to keep the pollution level as it is, that means at B0 level? Yes, it is possible. See, effectiveness of any regulation depends on how do you implement. Now it is possible sometimes for the firms to go for some illegal negotiation with the pollution control authorities. That means the officers who actually come to monitor the firm's performance. The firms can easily bribe them to bypass the regulation so that they can only increase their good output and keep the bad as it is. If they do so, then the firm can produce actually a good output which is Y double star. Now from the diagram it is very clear, when the firm is moving to AR direction, then the expansion in good output Y double star, which is higher than Y star. That means when the firm was moving to A1 direction, they were producing only Y star amount of output. But now, keeping the pollution as it is and moving to AR direction, they are enjoying even higher output. Now the question is it feasible economically for the firms to go for the illegal negotiation? Yes. It is feasible if the value of the extra output, that means if the value of Y double star minus Y star is more than what the bribing amount the firm needs to pay, then firm should always go for AR direction, not A1 direction. Because the firms have to pay a fine when they are caught, right? And there is no 100% guarantee that just because there is a regulation monitoring authorities will always be able to catch these violators. There is only a probability that a particular firm, if they are not complying with the standard, they will be caught, and if caught, then only there is a question of fine, and they can avoid the fine by bribing the monitoring authorities. So these firms can always calculate what is the expected probability, what is the expected bribe that they need to pay, expected fine that they need to pay based on their experience. So that is how they will calculate the expected benefit, expected cost, and if the expected benefit is higher than the expected cost, then it is always beneficial for the firm to move AR direction rather than moving to A1 direction, even though there is win-win opportunity. That is how, with this simple diagram, we argue that win-win opportunity may not always result in pollution abatement. Now, this particular hypothesis we have tested using empirical data from cement industry. We have used unit level data produced by annual survey of industry for the period of 1999, 2002, 2004-5, and what we did, we measure output by metric ton of cement and then CO2 by tons of CO2, carbon dioxide produced. Then we have used other inputs in the production as capital, energy, labor and material. However, CO2 emission data is not readily available at the farm level, at the factory level. So what we did, basically, we estimated the emission data from the fuel information, how much fuel you use, coal and other things. Based on that, coal, oil and other things, based on that, we follow IPCC's guideline, Intergovernmental Panel for Climate Change. What they do, they provide some kind of guideline to convert the fuel data into emission data. That is how we have indirectly constructed CO2 emission data. And then this is basically the summary statistics of all our inputs and outputs. In this context, we consider CO2 as an undesirable output. So that means we conceptualize a 2 output, 4 input production function. Okay, so one output is cement, that is called good output or desirable output. Another output is CO2, which is undesirable byproduct, undesirable output with detrimental impact on the environment. And there are 4 inputs: capital, labor, energy and material. Then this is how we have basically estimated the mean efficiency scores of the Indian cement firms. Okay, these are all number of observations, and this is the efficiency score under model 1 and model 2. Model 1 basically indicates when there is no regulation, and model 2 basically indicates when the firm is actually bypassing the regulation and moving towards AR direction. And we have also calculated the difference. Okay, so we have calculated efficiency following 2 model. In one model, firm is moving to A1 direction. That means they are reducing the bad and increasing the good. In model 2, they are increasing the good, keeping the bad as it is, which in the literature of data envelopment analysis called strong disposability assumption. Then we have calculated the difference in the mean efficiency. After estimating the mean difference in mean efficiency, we have also adopted one statistical test called Wilcoxon rank sum test to test whether the mean efficiency scores derived from model 2 is significantly larger than the mean efficiency scores derived from model 1. Why we have used Wilcoxon rank sum test, which is a non-parametric test instead of t-test? Because here efficiency scores are actually derived from mathematical model. That is why Wilcoxon rank sum test, which is a non-parametric test to basically check the difference between two series of efficiency scores. And then the result basically shows, apart from 1999, in all other years, our null hypothesis got rejected. What was our null hypothesis? That there is no significant difference in the efficiency score. Once it is rejected, that means we can say that mean efficiency scores derived from model 2 is significantly higher than model 1. That means the firm enjoys significantly higher amount of output if they move AR direction. That means in a situation wherein firms are trying to only increase their good output, keeping their bad as it is. And this points out to our hypothesis that win-win opportunity may not always result in pollution abatement. Then what is the solution? The solution is, we have examined two alternative scenarios. Let us first assume the case 1. In terms of the diagram, I will go back to the diagram once again. We first assume the initial level A is within the regulatory limit. That means whatever the firm is producing in terms of the bad CO2, that is within the limit. For example, let's say that if the standard says that 10 kg of CO2 the firm is allowed to produce per ton of cement, let us assume that the firm is producing only 8 kg of CO2 per ton of cement. So that means we can say that the initial position of the firm is within the regulatory limit. And if it is 12 kg of CO2 per ton of cement, then we'll say that the firm's initial position is beyond the regulatory limit. So we will discuss the implication of these two alternative scenarios. When the initial level of pollution is within the regulatory limit, then obviously the firms have no motivation to go for pollution abatement. Firms are not compelled to reduce their pollution further. Therefore, they can either increase their output, okay, by keeping pollution as it is, or they may reduce the pollution compared to initial level and move to A1 direction. Now, both these movements are Pareto efficient because in both the cases, they are either getting more output or getting more output and lower amount of pollution. So that means a movement through AR or AA1, both are Pareto efficient because both are showing an efficient situation because they are reaching to the frontier. Now, which particular movement the firm will choose, that is very hard to say in this context because that depends on the marginal benefit from extra output and marginal cost from extra pollution evaluated at the initial level. So firm will calculate what is the marginal benefit and marginal cost, right? Without knowing that, it is very difficult to come to a conclusion which particular path the firm will choose to reach the frontier. Only one thing we can say, that both are Pareto efficient. But when it is within the regulatory limit, firms are not compelled to go for pollution abatement. Now, case 2. Let us assume that the initial situation is beyond the regulatory limit. And in this context, the firms have two options. The firm can either go for pollution abatement or they can bypass the regulation through some illegal means if the benefit of doing so is higher than the cost involved. What is the cost? Cost is basically there is a probability that you might get caught and you might have to pay some penalty. So firm will calculate the expected penalty and the benefit, they will compare that, and that will help them decide what to do, to go for pollution abatement or to go for increasing output, keeping pollution as it is by illegal means. Now, the question here, since there is always a possibility that some of the monitors, that means monitoring agencies, the authorities, the officials who come for monitoring may involve in an illegal transaction with the non-complying firms, the policymaker can actually increase the transaction cost of such illegal negotiations. That means they can increase the fine. So even if the probability is only 110, if the fine is huge amount, then that can motivate the firm to stay away from the such illegal activities. Okay, it is undoubtedly very challenging task for the policymakers to effectively motivate all the firms then to go for pollution abatement, particularly so when the initial level of pollution is within the regulatory limit. However, one alternative solution we may think of. What is the solution? The solution is information disclosure, strategy of information disclosure. That means, to be specific, the policymakers may publicly disclose the level of pollution abatement by each and every firm. The pollution controlling authority may disclose their performance by giving them some green rating. And if such disclosure of performance happens, then what will happen? The firm will get some benefit from pollution control, which they were not getting earlier. Due to this green image, what they will have, what it will help them, this green image of the firms will help them creating a good reputation in the public. Okay, so when these firms they go for financing in the capital market, the capital market may give a positive feedback to those companies which are environmentally sound. The customers can prefer those companies' output which are environmentally sound. That means a good environmental performance, a good environmental image can actually benefit these firms to go from their pollution abatement activities. When we are living in a world where the issue of corporate social responsibility is placed with enormous importance, managers they realize that taking a lead role in ecological behavior could actually bring them with important benefits. So nowadays, corporate social responsibility, so that means doing business in a socially responsible way, is becoming more and more important. Regulators are now imposing a rule that if your annual turnover exceeds a certain level, then you must invest some amount of your money in a socially responsible way. If that is the case, then this pollution disclosure or disclosing the firm's performance about their abatement could benefit them by providing an extra edge. So that is why we argue that in a country like India, when formal regulation in the form of emission tax or command and other command and control mechanism fails due to improper monitoring, this type of informal regulation in the form of information disclosure may actually help them help them and induce them for better environmental performance, which is very, very helpful for developing countries like India, because we don't have that much of resources to monitor the firm's performance in terms of their pollution control activities. So in short, what we did in this paper, we made an attempt to empirically verify whether a potential win-win opportunity, that means higher amount of output with lower amount of pollution, is actually possible as a result of environmental compliance, and whether such win-win opportunity can always motivate the firms for pollution abatement. And the motivation comes from the proposition of Porter hypothesis. We use mathematical model, namely the directional distance function approach on firm level or factory level data in the context of Indian cement industry. And it has been observed that a potential win-win opportunity does exist in the industry. That means they could actually increase their good output, reducing their bad, if any such type of regulation was imposed. However, the Wilcoxon-Ransom test confirms that such potential win-win opportunity may not always result in pollution abatement, since regulation imposes a significant cost in terms of lower feasible expansion of output. We propose a strategy of information disclosure which might be of immense help for the regulatory authorities to incentivize the firms in favor of pollution abatement, and it may be used while formulating environmental policy for polluting industries in general and Indian cement industry in particular. Thank you.